can lower the memory pressure, we can lower the I/O pressure, and we can deliver a superior startup experience to customers. So, reliability and boot times are two of the fundamental scenarios that we care a lot about on Windows 7. I'd like to invite Mike and Sheila back up on stage, and we'll show you some more of the fundamental scenarios that we've been working on, and also the tools that we can use together to deliver these great experiences to our mutual customers. Mike?
Great. Thanks, John. So it's really awesome to see Windows 7 booted faster than Vista this early in the release cycle. Once we're even booted, we've done a lot to improve the memory usage and the graphics performance. This graph that you see on the screen here shows how in Vista we scale linearly with the number of open windows, so that's the amount of memory that's consumed by the system as you open more windows. In Windows 7, we use a small fixed set of memory that doesn't grow as we open more windows. And so what I'd like to do here is get two machines here side by side, and I'm going to show you a torture test script. It's a simple script you wrote that just opens lots and lots of windows. I mean, we've got Office windows and shell windows and IP web pages. And when I run it on Vista, what you're going to see is we're going to run out of memory. So at about 25%, you sometimes see a warning that your computer is running slow. And then you get at 30% a message that you've lost arrow. So we reverted to Windows Basic, we've lost the glass effect, and we've done everything we can as the system is running out of memory. Right? On Windows 7, so this machine is an identical hardware box, and you can see Windows 7 now running on the right. The same script results in no errors, it launches faster, and we actually still consume less memory on the system.
Right, that's great. And so we have a little over 70 windows on both systems. Gets to preserve the full user experience on Windows 7. And it's basically because we're letting the video card do its job of managing the memory for those windows. You don't have to manage it double.
That's right. We had some double buffering that was going on, and all of that has been eliminated. So even though we're using less memory, we actually have a faster graphics system going on Windows 7. So let me show you on this machine. I'm going to close down all these windows, which is actually pretty easy now with the new Windows 7 taskbar. You can close entire groups at a time. And yeah, it's neat. You probably saw the UI of the PDC demo that was publicized and on the web. And so now I'm going to launch a demo to show you Direct 2D. It's a new set of graphics APIs that are fully hardware accelerated and unmanaged.
That's not a show. You're trying to.
People love to look at. What I want to show you here, this is GDI rendering 100 Bezier splines. We're getting about 40 frames per second out of it.
That's looking at the title bar up in the middle there.
Yeah, right here is our actual frame rate, 45 frames a second. And that's up on the screen. Now, if I want to anti-alias this, I can turn on anti-aliasing, but it doesn't do anything with GDI. You have to go to GDI Plus in order to see nice, smooth curves. So here we've got 100 curves, anti-aliasing. This is really kind of going at full speed.
Looks beautiful, but it's quite a bit slow.
Pretty slow, 10, 11, 12 frames a second. I'm going to turn on hardware acceleration. And you can see we're at 60 to 70 frames a second. So here I'm hardware accelerated, anti-aliasing on, even faster than the low resolution version of GDI. If I turn anti-aliasing off, you can see that we actually get 4, maybe 5 times faster. So this is some of the power that we're unlocking of GPU in Windows 7 for graphics developers.
Right, that's great.
So power is important, but when you look at laptop customers, for example, what they care a lot about is battery life. And one of the best ways to simulate and test for battery life is through DVD playback. It exercises a lot of components in the system. And what I'm going to show you here is this movie Forbidden Kingdom playing on 2 identical machines backstage. So if we go side by side, we can see the same movie running on both PCs. And I've got a test application up here that shows that on the right, the Windows 7 machine is draining 13.4 watts from the battery. The Vista machine is 17.9.
And basically an hour more total runtime.
Same machine, same battery, same charge state, an extra hour of DVD playback time on Windows 7. That makes the difference between a cliffhanger of an ending and actually getting to finish the movie. And this isn't just one specific system. We ran the same test on a number of systems in our lab because you know that these results are going to be very hardware dependent. And when we compare the results, I have some data here that I can share in a moment. We saw a minimum of an 11% improvement between Vista and Windows 7. So a minimum of 20 minutes of improvement on any system that we had looked at in the lab.
Right, that's great. And I want to reiterate the point. Any specific system takes a lot of work for all the different components involved. It's really a thing that we need to work on together to drive this kind of improvement for the people sitting in front of the computer.
So in order to work together, it required an investment in more tools. So let's take a second and come back to these side-by-side machines. And let's look at the X-curve trace that was going on while these machines are running. So here we have side-by-side X-curve traces. So the Windows Performance Analyzer that's going to show us what was happening while we were running these movies. So if I highlight a region in the middle here,
Say 12 to 16 seconds.
about the same, and I pull up the summary table, my Windows Media Player was consuming about 12.6% of the CPU.
Versus here, it's over 15%.
So right there, you see that we're using less CPU, and even better, if I close that and scroll down, here's a graph of my CPU frequency over time. We ran on Windows 7 the CPU at the slowest possible frequency.
Almost the entire time. And you see across Vista, the CPU was raised to higher power states and frequencies pretty often during that period of time.
The bottom graph here shows my GPU, and we have, I think, different time scales, but mine averages about 5% cooler than yours.
Mine's just under 40, looks like yours is just under 35.
So this is one of the tools that's shipping today. The Windows Performance Toolkit includes X-curve. It includes a lot of the tools that you can use to analyze your products, your drivers, your systems as they come together and understand what's going on so that we can achieve this better battery life.
Right, an important tool to be using to drive this kind of system.
There's a new tool I'd like to show you now that's new in Windows 7. It's the Power Config tool. So this machine here on the right, I've doctored up. It's in the back. It's running a whole bunch of things that we know are bad about battery life for a PC. So if I look down at the system, I can see that I'm 98% charged, and I have 2 hours of battery life remaining. Now, this system ought to be able to get 4 full hours of battery life. But I've simulated here some of the problems that we found in our velocity program on this machine to show you how the tools can help you discover those problems.
Right, so while Mike is typing in the power config command, we talked a little bit about the things we've been doing in Windows 7 to work on saving power. As we went through the velocity learning, we saw a lot of things about just processes, sometimes drivers with other processes running that were just not letting the CPU do a very good job of getting to idle. So that's an important way that we want to help the system get to idle and stay idle. It's one of the principles we have for Windows 7. We did a lot of work in the kernel to better manage the system clock so we can keep the CPU at the minimum power state for an unbroken period of time.
Speaking of a long, unbroken period of time, 27